Yeah. Can anybody tell me what exactly we have studied in the last class? Hmm. Can anybody recall?
Determinant, we learned minor of a determinant, then adjacent of a determinant, adjoint of a determinant. Today we are going to learn specifically linear equations in two variables solving through matrices.
Thank you. Good. Very nice. So today we are going to study a system of linear equations. Right? System of linear equations means what? When in this there are two or more than two equations will be there, then we call it as a system of the linear equations. Right? So it may be there will be have two unknowns and two equations. There may possibility that there will have three unknown and three equations. There may have the possibility that four unknowns and four equations. Sometimes it is not a guarantee that number of the equations should be same as the number of the unknown. It may change. Then in that case, is that system will have solution or not? That we have to check. For checking that, we'll have some theoretical background when we can say that this particular system will have the solution. When that particular system will not have solution, we don't know that system will have one solution or two solutions or multiple solution or infinite number of the solution, right? So to address all these questions, let us start with today's this system of the linear equations. So I will write first in the general system of linear equations. Linear equations, right? So first I will try to put in more general form. Then we can study a particular cases. It is very easy to study the particular cases. So that's why what we can do first. Let's start with the more general cases, right? So what is the more general cases? Suppose I will write a11 x1 plus a12 x2 plus so on a1 n x n is equals to supposed to be an b1. This is the second equation a21 x1 plus. Is it visible what I am writing?
Yes,
Yes.
sir.
Thank you. A22 x2 plus so on a2n xn is equals to b2. A31 x1 plus a33 sorry a32 x plus so on a3n xn is equals to b3 and so on am1 x1 plus am2 x2 plus so on amn xn is equals to bm. Right. So what is this? This is, can anybody tell me how many equations are there and how many unknowns are there?
They are M equations.
M equations, okay. And how many variables are there?
N variables. Oh, no, 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 yeah, how many yeah, there are xn variables.
That is xn means what? N variables, na? Number of variables I'm saying.
N.
Correct? Means one x1 is one variable, x2 is another variable, x3 is another variable, so on xn. So there are n variables are there, and this number of the equations are m equations. Alright. So this is we call as a more general system of linear equation in n unknowns and m equations. These are the equations, system of equations having number of unknowns, n unknowns means these are the not known to us. We have, our task is to find these unknowns, and these are the equation, number of equations are m, right? So our task is to find these unknowns, say x1 x2 x3 exponent, so on xn by using the different matrix methods, right? So let us try to write this system of linear equation into matrix. So how we can write? I can write this same system in a matrix form as a11, a12, so on a1n, a21, a22, so on a2n. Is it visible? A31,
Yes, sir.
A32, and so on A3n, so on AM1, AM2, and so on AMN. Right? If I will multiply this matrix by x1, x2, x3, and so on xn, so you will get this LHS side, which is this equals to this column vector, say b1, b2, b3, and so on bm. Is it clear how we can write this? We wrote the system of linear equation into matrix form, simple matrix form, right? And now to very easy, right? And similarly, what we can do, we can write, if you have this matrix, we can convert matrix into system of linear equation. If you have system of linear equation, you can convert it into matrix, vice versa. Is it clear how we wrote this? Yes.
Yes, sir.
Okay. Now our task is that, so this is one equation, one matrix says, what is the order of this? Its order is m cross n. Correct? What will be the order of this? This is m cross n. What is the order of this? M cross 1. What will be the order of this? M cross 1. Right? So these are the different matrices. So in general, if I can write, if I can denote this matrix is as A, which is a m cross n, right? Into this x is equals to, suppose if I write this as either small b or capital B, something like that, no problem. So therefore, now what I did, I have converted system of linear equation into matrix form, and I wrote this matrix into
Sir,
matrix. Yes,
it's capital B.
no problem. That is your choice. You can write small b or capital B. Doesn't
Okay,
matter,
sir.
because why I am writing the small b, because it is a column vector. Okay, let's it be big if it is okay, fine. Okay, no problem. That is your choice. So a x into b. This is your, now what is, this is a matrix equation. We call this as matrix equation. So we converted simple equation into matrix. Then matrices we wrote in equation form. Why we called calling equation form? Because here is x. That's why we call it as a matrix equation. Right? So now
Sir, there is a confusion I have.
which one?
For this one, X1, for the X1, you've written for the order M cross 1. But for the X, you've written X to XN. So shouldn't it be N to the N cross 1?
Which one? Which one? Sorry. These are
For
the
the
m rows.
X, sir. X1, X1, X2, X3, shouldn't it be N cross 1?
N cross 1. No, number of equations are m, na? So it will be m.
Okay. Okay.
Right? Number of equations are
No,
from
sir,
many.
I got confused. I got confused because of XN.
Because you are thinking that these are the n, na? That's why you
Yes,
are
sir.
confusing this n and this n, right?
Yes, sir.
Yeah. No, it is not like that. So because see, if I write, see now simple, I will tell you how it is clear. So now I want to obtain this equation from this first row. See, a11 x1 plus a12 x2 plus a13 x3 plus so on a1n xn is equals to b1. I have what first equation?
HM.
Right?
Yes, sir.
So it is like that. So now what we did, we converted system into matrix, matrix into matrix equation. Now, what are these A11, A12, and so on? All these are the coefficients. So what are these? These are all coefficients are some numbers. That is are the known. Right? Means what? This whole matrix is known to us. This is known to us. So what is the unknown? Unknown is this much only. Unknown is this much only. And this is also known because this is also constant. Some constants are there. B1, B2, B3, so on. All are the constants. So I will write that. So Aij and Aij and otherwise no need to use much indices. Short I can write. Therefore, A11, A12, and so on, A1n, A21, so on, A2n, and so on, AM1, and so on, AMN are belonging to set of real numbers. And B1, B2, so on, BM are also from the set of real numbers. Are known constants. Is it visible? What I'm writing? What are these? These are some number 1, 2, 3, 4, -1, -2, -3, 0, like this. These are the some known. These are the also some known. Means unknown is this only. So if I can write, otherwise, before moving ahead, so here we have to see now. Right. Okay. Let me go one more step. Suppose if I can multiply this equation by A inverse, what will happen? If I can multiply by A inverse on both the sides, so what will happen? A inverse A into X is equals to A inverse B. So what is A inverse A? It is I. X is equals to A inverse B. So if you can multiply identity matrix with any matrix, then it will remain same. So X is equals to A inverse B, right? So this is, so if you want the solution of this, so what you have to do? You have to find this A inverse and multiply with this matrix B. So you will get these unknowns. But now there are some situations are there. So now here you can see the M and M, right? There are two things are there. So which is very important. Yeah, here if you can see, these are the two important things are under this. So how many equations? Number of equations are M, and number of unknowns, or I can say variables, are how many? So these are the n, right? So you know that when inverses exist, when inverse will be exist of the matrices, there are two conditions, right? When it is possible, if m is equals to n, right? So based on the value of m and n, there is a concept of that this system is either consistent or inconsistent, right? Consistent or inconsistent. Inconsistent and consistent means what? If this system will have unique solution, means only one solution, then you can say that the corresponding system is a consistent. This given system is a consistent only when if it will have unique solution. So what are the possibilities that this system will have unique solution? First, it should be a square matrix, right? Which is the corresponding matrix we have obtained. It should be a square matrix. Either it should be m cross m or n cross n, right? So this should be a square matrix. One second, for the existence of the universe, what we want that particular matrix should be a non-singular. Means what? The determinant of this matrix should be different from zero. Means if you want to say that this system is consistent, only when you should have number of equation is equals to number of unknowns, and the corresponding matrix should be a non-singular. Then and then you will have only one solution or a unique solution. That time only we can say that this system is consistent because it's having a unique solution. This is one. What about the inconsistent? Inconsistent will have two options. First, it will have same number of equations, number of unknowns, but this corresponding matrix will be a non-singular, right? Corresponding, sorry, no, sorry. Here in inconsistent, there are two choices. One, the number of equations are not same as the number of unknowns. Means what will happen if you can try to solve that? You will get infinite solution or no solution. That kind of system we will call as a inconsistent. Is it clear? There are two concepts. Is it clear?
Yes, sir.
Sir, can you repeat the inconsistent?
Okay. When we can say that system is considered inconsistent, if number of unknowns and number of the equations are not same, means what? The corresponding matrix will not be a square matrix, right? Means what you will get? You will get either infinite number of the solutions or no solution. We'll see some example based on that also how it is, right? So that kind of system we can say that inconsistent solution, inconsistent system. Or there will be another case also. There will have number of equation is equals to number of unknown will be same. You will get a square matrix, but this will not be a singular matrix. It will be a non-singular matrix. So there also you will get a inconsistent solution. That is also we call as dependent solution and independent solution. I will not go in that way. Again, it may create confusion. So to solve such a systems, we have three different methods, right? To solve such a system, Ax is equals to B. Because any system of the linear equations, we can write in the form of the matrix form, right? We can write it in the form of the matrix form. So there are three methods are there called as, one is called as a substitution method. You can substitute and try to solve it. Second is called as an inversion method. So like this, you just do it in simpler way that. And another is called as a method of reductions. Means what? We'll reduce the equations, right? We'll convert these equations into matrix form and we can reduce the equations. So there are different Gauss elimination, Liouville decomposition. There are so many different methods are there. Okay, so we are not going to see so many methods. Only we will see the two important methods. One is called an inversion method. What is the inversion method? So this system of linear equations we have converted into matrix form, and this matrix we have wrote into matrix equations. Just if you can multiply by A inverse on both sides, so finally you got X is equals to A inverse B, right? So we know that how to find the A inverse. We know the matrix multiplication. So you just multiply these two matrices, so you will get the corresponding solutions. Okay, is it clear what I said till time? Yes,
Sir.
Aditya, is it clear?
Yes, sir, it's clear.
Yeah. So anyone have any doubt? Okay, thank you. So we'll go for the first method called as an inversion method. So First we see the simple 2 cross 2 means 2 equations and 2 unknowns, and then we can move to the 3 cross 3. So can I remove this, or somebody is writing anything on this board?
Sir, you can rub it.
Yeah, thank you. So you may think that if we are solving simple problem, then why there is a need to study so much things. But if you have number of huge equations and huge unknowns, so at that point of time it will be important, right? So this will be first example, which is a very simple example. Solve the following system of equation. Solve the following system of linear equations. So here first we'll consider as a 2 cross 2, sorry, 2 equations in 2 unknowns. 5y is equals to 1, 3x plus 2y is equals to 7. All right. So we'll try to solve this. So first, as it is the equation, we can write as it is. So first we'll write the coefficient. We call it as a coefficient matrix. So first, as it is, we'll write the equations. So we have what we have. We have these equations. We have these equations. Say 2x plus 5y is equals to 1, and 3x plus 2y is equals to 7. These are the equations. So therefore, coefficient matrix we can write. Coefficient matrix. So what is the coefficient matrix? That is called as an A. So what is your A here? A is 2, 5, right? 3, 2. So what are the unknowns? So what is your
X and
yeah, thank you. X is unknown is your X and Y. And what is your B? 1 and 7. Therefore, your matrix equation AX is equals to B will write, and we know that X is equals to A inverse B. So we have to find its A inverse. So X is nothing but this A inverse I will write 2, 5, 3, 2, and its inverse I will write like this into this matrix B. So it is 1, 9, 7. Can anybody tell me what is the is different from 0 or not? So you can use the adjoint method and try to find the solution of it. So what is the determinant of A? Determinant of A is nothing but 2, 5, 3, 2, right? So this is nothing but 4 minus 15, right? I'm right? Minus 11. So it is a different from 0, right? It is a non-singular matrix. Therefore, we can find the solution of this inverse of this particular this. So as per the your this adjoint method, you know how to find that A inverse is nothing but adjoint of A divided by its determinant, right? So this is the same as, so in adjoint, if you can see, if you can remember, for 2 cross 2 it is very easy, right? For 2 cross 2 it is very easy. You have to just transfer this and this and this and this and change the sign of this, I think. Let me check. If it is A, B, C, D, so what is this? This will become D here. If I can this, and yeah, this is nothing but this. Sorry, B for B, it is a C, na? It is, sorry, A, it is a D, it is a C, and if I want to find this it is a B, and if I want to find for D, so it is A, and what are the odd positions? So this is the one position, so it is odd position and it is odd position. Means A inverse of this is nothing but you have to exchange D, means it is D is D and C. So this, which are the D and C, this D and C, right? And B and A, first B, then A, and minus sign of this. So minus of this into 1 upon 11. Is it correct what I did? Can anybody check the inverse of this matrix is the same? What I did?
Sir, I got minus 2 by 11, then 5 by 11, then minus 3 by 2, and minus 2 by 11.
This only changing in the minus sign, isn't it? So let me divide this. So then I will check it either my thing is correct or not. Minus 5 by 11 and 2 by 11. Let me check. This is minus, correct. Yeah, this is minus 11, na? Yeah, you are correct. So this will be minus, this will be plus, and this is minus, so it is plus, and it is. Now your answer and my answer is same. Yes. Hello.
We have to transpose it, right? Like after finding the minor, then we will have to change the sign. Then we have to
Correct.
transpose it.
Yes. To, yeah, we have to transpose it. So rather than writing this minus, let me here. Okay, so this will be, then I will take its transpose. Correct. You are correct. So will you tell me that again? So by the adjoint methods, first I will write directly what is that adjoint or inverse of this is. By you can do the calculation and see you are getting the same or different one. 2 minus 5 minus 3 2. Is it right?
Yes, sir.
Yeah. Because first what we have to do, we have to take its minor, right? Then it's a cofactor, right? Cofactor means it will be transposed. Then you will get the adjoint. Correct?
Yes, sir. Yes, sir.
Minor, then in cofactor the signs will be changed, and in adjoint we have to take the transpose of the cofactor. So then the positions will be changed, and then you have to just divide it by this determinant. Okay, so this is your. I will not divide this 11 because we are going to multiply here again this matrix. That's why I am not multiplying by this minus 1 by 11. So I will write now x is equals to minus 1 upon 11 into 2 minus 5 minus 3 2 into this column matrix, say 197, right? So let us multiply with this minus 1 upon 11 into, so 2 into 1, so it is 2 plus, here is minus, so it is minus 5 sevens are, right? Then right, first into first, correct? Second row to second row, first row to first row, second row to second row. So it is minus 3 and plus 14. Okay, so if you can solve minus 1 upon 11, so it is minus 33, and what is this? It is 11, all right? And if you can divide this, so minus 1 by 11, so it is minus minus get cancelled. So 33 means it is 3, and it is minus 1. Is it correct? So either our solution is correct or not. How we can check? just put this solution in this equation. So value of x is what? 3. 2 3s are 6 plus 5 into minus 1. So it is a minus 5. So is it coming 1? Okay, it is satisfying. Let us put this solution in this. It should satisfy both the equations, right? So 3 3s are 9. Okay, plus 2 into minus 1. So it is minus 2. So it is coming 7. So it is satisfying both the equations. So therefore, whatever the solution we have obtained here, so this is nothing but what? This is same as x and y. So therefore, x is equals to 3 and y is equals to minus 1. These are our solution. Is it clear?
Yes, sir.
So this is for 2 cross 2. It is very simple in 2 cross 2, right? But if you can go for 3 cross 3, you have to do little more stepwise, and you have to find the solution of it. So let us see one more example for 3 cross 3. So if anyone have any problem or any ambiguity to understand this, then please tell me, I can repeat again. So here I a little jump. I didn't did the procedure of this. Okay, so you know how to find the adjoint of these, transpose of this. So that's why I directly wrote how to find the A inverse of this particular matrices. Right? Already I have found, so I wrote that and just I did the multiplication of these two matrices, and you get the final solution. So can I erase this?
Yes, sir.
Okay. Let us see now three equations and unknowns. One example, and then we can move to the next question. Or you can say next minute. So this is our which class? How many classes we have finished? This is third. Is it this third class or fourth class?
Fourth.
Fourth.
Yes, sir. Full.
2x plus y plus 0z is equals to 1. X plus 2y plus 2z is equals to 3. So now we can try this by.
So for
I
the
will write that
second
as coefficient.
equation, it is 2x plus y plus 0z.
Means nothing. Z term is absent.
Oh.
Z term is absent. That's why I write 0 0. Or you can write directly like this also. No problem. For simplicity, I wrote in that way. Okay, so let us try first. We'll write coefficient matrix A. Yeah, can you tell me the coefficient matrix?
1, 1,
One.
2,
Mhm. Yeah, next row.
2, 2, 1,
Yes.
0.
Okay,
1, 2, 2.
1 2 2. So what is your X matrix here?
X, Y, Z.
X, Y, Z. And what is your B
Mhm.
matrix?
2, 1, 3.
2 1 3. Okay. So therefore we are interested to find the A inverse. So before that I will write determinant of A. So what will be determinant? Can I go direct method, direct way, or should I go in simple steps? So let's write 1 if I can put 1 into eliminate this row and this column and find the determinant of this 1 0 2 2, okay, minus 1, so 2 0 1 2 plus 2 into eliminate this and this, so it is 2 1 1 2. All right, so this is same as 1 into, so 2 into 2 minus 0 minus 1 into, it is a 4 minus 0 plus 2 into, it is 4 minus 1. So if you can simplify it, so it is 2, so it is a minus 4 plus, so it is 1, it means 3 6. So what it is coming, so 4 will go, means 2, it is 4, correct? Na? I am correct?
Yes, sir.
Which is the different from 0, right? So means it is a non-singular matrix. So means there is a possibility to get the what I can say, possibility to get a unique solution. Okay, let us move to the next one. Now what we have to find? We have to find the minor of A. I will find minor of A. Minor of A. A is nothing but how we used to find, keep this and find the determinant of remaining one. So 2 into 2 it is means 2. So minor of this element, this remove, this remove. So it is a 4 minus 0, it is a 4. Minor of this element, remove this. So 4 minus 1 means it is 3. So minor of this element, so remove this and remove this, means this is the remaining 2 minus 4, so it is a minus 2. Please check it, if I am wrong please correct me, right? So minor of this element means what, remove this and remove this, so it is a 2 minus 2, it is a 0. So minor of 0, remove this, so it is a 2 minus 1, so 2 minus 1 is 1, okay. So minor of this element, remove this and remove this, 0 minus 2, so it is again minus 2. So minor of this element, remove this and this, so it is a 0 minus 4, so it is minus 4. And minor of this element means remove this, so 1 minus 2, it is 1 minus 2 is minus 1. I am correct? Please help me while doing the calculation, sometime in hurry I may wrong. Is it correct what I obtained the minor? Yes. Is anybody doing? So now we'll have a cofactor of this A. So what will be your
Sir,
cofactor?
it's correct.
It is correct?
Yes, sir.
Is it correct?
Yes, sir.
Okay, thank you. Now what will be the cofactor? Cofactor means changing the sign, odd positions where the sum of the indices are odd. So first position is A11, so it is A1 position, no change. So it will be changed, minus 4. So A12, here is A13 means 4, no change will be there. In 3 cross 3, diamond positions will be changed, means this, and this, and this. I am correct? Because A31, right, these positions will be changed, rest will be as it is. So this minus 2 become plus 2, and this 0 is as it is. 1 will become a minus 1. So minus 2 will be as it is. So it is a minus 4 will become plus 4, and minus 1 will be as it is. So this is your minus. So cofactors. So what is the adjoint? Adjoint is nothing but the transpose. So adjoint of A is nothing but just we have to transfer. So write first row as first column. 2 minus 4, 3 minus 1 minus 1. Right? So this you got the adjoint. You know the adjoint. You know the determinant. So A inverse is done now. So just therefore A inverse is nothing but just this. So A inverse is nothing but adjoint into determinant of A. So I will not write this matrix because I am having a less space. So what I can do, I can write now the direct equations. What was the equation? Our equation Ax is equals to B, x is equals to A inverse B. So A inverse is already we have got. So your x is nothing, x is equals to, we have to write A inverse. So A inverse is nothing but 1/4 into this matrix 2, 2, minus 2, minus 4, 0, 4, 3, minus 1 into your B matrix. Where is B matrix? Here. So 2, 1, 3. Right. So let's do this multiplication and let us see what we can get it. So it is 2, 2, 4 plus 2 minus. So minus 2 and this, so it is again 6. So first it's coming 0. Minus 8, it is plus 0 plus 4. 3 to the 6. Minus 1 into 1 is minus 1. So you end minus 3. So this is nothing but 1/4 into. So it is 6, 6. It is become 0. Minus 8 plus 4. So it is minus 4.
Plus 4 or 12,
Yes.
like the second one. Whether it's 0 plus 4 or 0 plus 12.
Where?
Like minus 8 plus 0 plus 4 or
Huh?
it's 4 into 3, no?
It is minus 4, na?
No, sir. I'm asking like when we are multiplying it's 4 into 3, no?
So see, this will come how? Minus 4 into 2 minus 8. 0 into 1, 0. 4 into, right, you are correct. Sorry. 4 3s are 12. Thank you. So what about this? 3 2s are 6. Minus 1, minus 1, minus 1, 3. So minus 3. Thank you. So what about this? It is correct. First row is correct. 4, 2, 2 minus 6. Right. So what will happen here? So plus means it is plus 4. Right. And what will be this minus 4 means it is 2. So if you can divide all these things, what will happen? First is 0 as it is. 4 you divide, you can do 1. So it is 1/2. Right? So your x is equals to 0, y is equals to 1, and z is equals to 1/2. Let us check. Simple equation is this. So we can put y is 1 is equals to 1. It is satisfying. Here x is equals to 0, y is equals to 1. So 1. And 2 upon means again 2. Right? It is satisfying. It is a 0. 2 into 1 it is 2. And again it will cancel. 2 plus 1 is 3. So this is a correct solution. Okay. So in this way we can find the solution of 3 cross 3 equations by using matrix method, and we call this as an inverse matrix method. Is it clear?
Yes, sir.
Because of a less space, I am trying to skip some of the steps. If you have any problem in between the steps, you can tell me. Again, I will remove and I can explain that in a particular way. So can I write few example for you people as a homework? Okay, so I will write some example. So I will change here itself 2x minus 2y. This will be one example. So let me change this also. Okay, please write this as a first example. Can I erase all these things?
Yes, sir.
Yes, sir.
Okay, thank you. So this will be first example. Please write down the second example. The second example will be like this: x minus 0 y plus 3z is equals to 4. Again, x plus y minus z is equals to 6. X plus 2y plus 3z is equals to 9. Okay, so this is one and this is second as an moment. So do you need a small break?
Yes, sir.
Okay, so we'll have a small break. Then after that, again I will come back and we can see another method how to solve this system of linear. Yes, so we have seen this inverse method, how to find the solution of system of linear equations. Now there is another method which is developed by another mathematician called as Gauss Fendrich. So he is one of the, or sometimes they called, he is an father of the matrix theory because he developed so many theories based on matrix, right? So let us see one method called as Gauss elimination method. So there are so many methods are there, but we are going typical one or two methods because we there is no need to study more methods as an we are a social science student. Just you should know which is one of the basic and which is the easiest one and which is prominently they are using nowadays for solving the system of the linear equation. So we'll take this. So I will tell one more thing about this. This Gauss is such a big mathematician, and he proved so many results with respect to the matrix theory. So on the name of his, there are so many awards are available called as a Gauss award, and which is approximately is equals to. So they used to give 10,000 euros if you can do good developments and further developments in the matrix, which is knowable and which is innovative and which having so many usefulness and applications. So you may get as this prize. So already I have told that Gauss discovered another important method where to fix the position of the planets in the solar system, right? To fix this position of the planets, he discovered that another method. I will not go for that. So, what is this particularly? We'll study this Gauss elimination method. So now here I will restrict myself for 3 cross 3 equations and 3 unknowns. So rather than going for n cross n, so it is you can extend it for any number of the equations, right? A11 x1 plus A12 x2 plus A13 x3 is equals to supposed to be B1 and A21 x1 plus A22 x2 plus A23 x3 is equals to B2 and A31 x1 plus A32 x2 plus A33 x3 is equals to B3. Suppose this is the system of the linear equations. Now we have to convert this system of linear equation into augmented matrix. In which augmented matrix? What is that? I will write. That is only a form of writing, right? It is one way of the writing. That's we call as augmented matrix. So you have to convert this into augmented matrix. Means what? Write the coefficient matrix A11, A12, A13, and put this a dotted line and write this coefficient as an B1. Okay. Then A21, A22, A23, B2, and A31, A32, A33 into B3. This is called, we call it as an augmented matrix. So convert system of linear equation into augmented matrix. Then way that you have to convert this matrices, particularly these matrices, in such a way that all the diagonals, all these diagonals should converted into unit into one, and this lower diagonal should be converted into zero. This converted into one by using your usual elementary operations, right? So what will happen if I will, that is nothing but called as a row echelon form. Is it clear what does it mean by row echelon form? What we have to do? We have to convert these diagonals into one and convert the lower tridiagonal, tridiagonal this entries into zeros by using your elementary operations. That form we call as a row echelon form. Means in general it is like this. So 1, 1, 1, whatever it may be here, it should be 0 here, right? So there is doesn't matter what here either k1, k2 like that, whatever it may be, doesn't matter. You convert this matrix into this row echelon form, right? Once you will convert, what will happen? It is very easy then, right? So what does it mean? What does it mean? So once if you will convert this into row echelon form, so what will happen now? So if you convert this, so in row echelon form, so what will happen? Say 1, A12, A13. After doing some operation, these numbers may change. So that's why I will write dash. Means this is the changed numbers. Okay, dash means what happened? After doing the row operations and column operations, the numbers will be disturbed, right? So no new numbers will come. So that's why I'm putting this dash as an just understand. So here 1 and here A23 dash, and here 0 and 0, and here 1, here B2 dash and B3 dash, right? So all these converted into this form. What does it mean? So this is nothing but if you want to write in the equation form, so what will happen? This is nothing but we will take from back to front. That's why sometimes we call it the back substitution methods as well, right? So this is nothing but what 0x1 plus 0x2 plus x3 is equals to b3 dash, right? So this is 0 means directly what you got x3 is equals to b3 dash, right? So if you write equation for this, what will happen? So it is 0x1 plus x2 plus a23 dash x3 is equals to b2 dash. So now you know the x2 from the you know the x3. So you will can get x2 is equals to b2 dash. If I take this minus here a23 dash, what is x3? X3 is b3 dash. So b3 dash. Similarly, put all these things in this equation, you will get x1. So in this way, we can find these unknowns x1, x2, x3 by using the back substitution method. So this whole procedure is nothing but the Gauss elimination method. Now you may ask me the question that, sir, already one method is there. What is this new method? It is also giving the solution. Can anybody tell me that what is the difference between this method and that method? So why we have to study this different one? Already one is existing. So why another method has to come? Yes, please. Is it clear? First, you tell me what I said, what I have discussed. Is it clear?
Sorry, can you explain it once again? I got confused. What happened?
Okay. Yes. So I can explain again. Then I can see what we did. whatever the system of the linear equation, we wrote as an augmented matrix. Means what? We didn't did much anything. They gave as an augmented, means what? We added these constant in this matrix and we operate rows or column operation. You can operate either rows or or column and convert this matrix into row echelon form, means this form, row echelon form, this particular echelon form. Okay, so particular what we did, we used the row operations R1 minus R2, R1 plus R3 to make these entries 1 1 and make these entries 0 0. So once you convert this matrix in this form, then you can write this equation for last row. What will be the equation? 0x1 plus 0x2 plus 1 into x3 means x3 is equals to b3 dash. So all are 0, directly you will get the value of x3. x3 is equals to b3 dash, right? Now you can take this equation for finding the x2. 0 x1 plus 1 into x2 means x2 plus a23 dash x3 is equals to b2 dash. So already you know x3, so you have put it, therefore x2 is equals to b2 dash. Take all this in right side because this is known. So a23 dash and x3 is what? b3 dash. So similarly you can write the x1 equation for this one. So x1 plus a12 dash x2 plus a13 dash x3 is equals to b1 dash. So in that you know x3 and x2, put all these things, so you will get the x1, right? So in this way we can find the unknowns x1, x2, x3. This total whole procedure is nothing but the Gauss elimination methods, because we are eliminating one by one and taking a back substitution. Sometimes it's called as a Gauss elimination back substitution method also. So is it clear?
Yes, sir.
Yeah. So now you tell me what is the difference between earlier method and this method. Both are the method for obtaining the solution of the system of the linear equations. So what is the difference between these two methods? Why we have to study this one again? Already we have wasted so much money, so much efforts and time to study that inverse method. So why we have to study this another one?
So I think substitution is much easier than finding the A inverse.
Okay, that's good. I need another smart answer. This is a good right answer.
So this one consumes less time, lesser
Yes.
amount of time. It saves
Correct.
a lot of time.
Right, exactly correct. So if you can see the number of steps involved in this procedure and number of the steps involved in earlier steps, right? So means what? Now we are having 3 cross 3. There are 3 equations and 3 answers. Suppose if I will have 100 equations and 100 unknowns, then it is very difficult to find the inverse of that. Rather than that, it is a very easy steps. So not only that, you in that method you have to find first its determinant, right? After determinant, you have to find its minor and then cofactor. Then you will get the adjoint. Then after adjoint, you will get finally A inverse. After that A inverse, again you have to multiply. Then you will get the final answer, right? These many steps you have to do. Again in minor also, how many steps are there? You are finding minor of each and every element. Means program in a computer, so how much steps it will take? So you, that's why or as an algorithm, if I want to write, and a general program if I want to write, it consumes more steps. And if any such a program having more steps, means your CPU will sleep for some time, your screen will switch off some more time, and they can make wake up after some time. So this much of things will they are involved, right? So that's why here if you can see straightforward, how much easier it is. Okay, we can see one example and you can easily get to know that really this method is efficient and fast and easy. So all these things are there, right? So let us solve one example. We can solve same example what we have solved earlier. So then you can compare also if you want, and thereafter I will give the. So we can take the same example, say x plus y plus 2z is equals to 2. Say 2x plus y plus 0z is equals to 1. Say x plus 2y plus 2z is equals to 3, right? So this is your system of the linear equations. Now what we have to do, as per the procedure, we have to convert into augmented matrix. Okay, so therefore the augmented matrix is, you check the spelling of the augmented matrix and write it. Okay, augmented matrix is nothing but, so first you write coefficient matrix 1 1 2, right? Here 2, so 2 1 0 1 1 2 2 3. Okay. Now what we have to do? We have to convert this into, means what? We want all are one. So already here one is there, here one is there. Only we have to one here. So now what we have to do? First we have to make this person 0, this person 0, and this person 0. These are the three tasks are there. So first target will consider this person has to be 0. Okay. Then we'll come to the this person has to 0, and then we'll come to the this person has to be 0. These three steps we will do. So what is the operation? By using R1 I can do that easily. So operation on which row? R3. R3 minus, yes,
1.
is it correct? Yeah, R1. So means operation are doing on R3. So R1 and R2 will be same. Means remains as it is. 1 1 2 2 1 0. So these will be the same. So only we are doing this. So 1 minus 1 it is 0. So 2 minus 1 is 1. So 2 minus 2 is 0. So 3 minus 2 is 1. Okay. Now, see already you got this. So you can interchange, then z is equals to 0, or directly. There is no need also to go for much. So because already you got from this equation one. If you can try to write the equation for this, so what will happen? You will get this. So from this you will get x1, right? Then x3. Okay. So now if I want to try to write the equation for the last one, what will happen? 0x1 plus x2 plus 0x3 is equals to 1, right? So what it implies? X2 is equals to 1. Is it correct? So now I will write equation for this. What is that? 2x1 plus x2 plus 0x3 is equals to 1. So now x2 is known to you. So let's take that side. So 2x1 is equals to 1 minus this x2. Right? So 2x1 is equals to 1 minus 1. So it is a 0. Right? So let us. I'm correct?
But
In
sir,
taking
you did not take the diagonal as 1. Like you did not convert the whole diagonal as 1.
all diagonals, na? So it is
Yes,
the,
sir.
yeah. Again, you can do the same, but from this also, because what happened here? So here there are 2 zeros and only 1, right?
Yes, sir.
Generally, in row echelon form, what will happen? So one, some say A12, A13, 0, this is again 1, and A2, 3 dash, dash, 0, 0, and 1. Right? So what will happen here means there are these two variables are 0 and you can get the direct, right? So here also what I thought, these two variables are 0, so I can get one variable directly. That's why I did not thought, and no need also, right? In that case. Okay.
sir.
So you can do this way also. If we can want that also we can do, but see again operations will increase, right? Operations
sir.
will again increase. So that's why I thought it's easiest way to find that. So you what you got? So you got your x1 is equals to 0 from here. So now we'll write equation for this one, last equation. So x1 plus x2 plus 2x3 is equals to 2, right? So what is known to you? You know x1 and x2. So x1 is 0 plus what is x2 is 1 plus 2x3 is equals to 2. So 2x3 is equals to 2 minus 1. So x3 is equals to 1 by 2. So you can check earlier our solution of this system of linear equation. Many steps will be involved, right? Is it okay? I think solution is correct, which is we have solved this last time as well. Or you can check, verify here, two, this and one, what is x? Here I have, sorry, one, I have used here x1, x2, na? And here I am putting xyz. No problem, either you write in xyz or x1, y1. So I will write here if you want x1, x2, 2, x3. So 0, x3, here is x3, x2, x2, 1. Right. So 2x1 plus x2 is equals to should be 1. So 2x1 means where x1 is 0, so x2 is 1 means 1. Right. It is satisfying. Already we have solved. Is it clear how to do this?
Yes,
Or
sir.
else you want one more example, or should I give more example for exercise? Can I write two more example as an exercise?
Yes, sir.
Yes, sir.
Yeah. Okay. So please go for this homeworks. 4x plus 2y is equals to 1. 3x plus y is equals to 2. This will be 1. Second equation, 2x plus y is equals to minus 1. And x plus y is equals to 2. And let me write few more examples for 3 cross 3. So this is the third example, x minus y plus z is equals to 8. 2x plus 3y minus z is equals to minus 2. And 3x minus 2y minus 9z is equals to 9. Okay. And this will be another example. I will write 6x plus 3y plus 2z is equals to 6. 6x plus 4y plus 3z is equals to 0. And another is 20x plus 15y plus 12z is equals to 0. Okay. So let me write one more example. We'll discuss the things later. So please try to solve these equations by in this method and that method. Both the method you can use for the practice. Say 2x minus 3y plus 4z is equals to 6. So these are the few examples. Please try to solve these examples and find out the solutions. So in next class we will this how we can write some of the word problems or practical problems in a system of linear equation, and how we can try to find the solution of such a system of linear equation by using any one of these methods. Yeah, is it clear everything?
Yes, sir.
Yes. Yeah. So can we stop, Aditya now?
Yes, sir. We can, sir.
Yeah. So